Okay, so here I have A's Level Statistics Paper 1 with me, and this is the October-November paper of 2024. So this is 9709, Winter 2024, the most recent one. It just happened like 3 days ago, and this is Paper 5, Variant 3. And today we'll be going over a probability question, arguably the hardest part of the exam. And this one was geometric probability combined with like conditional probability like Bayes' theorem. So let's look at the question. And by the way, this is an exclusive video, so no other channel will be covering this paper. This paper will only be released to the public in like many months, be like next year until Cambridge releases it, but I'll go over this problem right now. So a factory produces chocolates wrapped in gold and red foil, as well as unwrapped chocolates. So the probability of getting gold is 30%, red is 25%, and unwrapped is 45%. Now this question isn't word for word. The actual question is a bit different, but the idea is the same. So some dude picks chocolates at random from the production line. Find the probability that the second chocolate is the first. Keyword here is first. So the first gold chocolate, given that the fifth chocolate is the first unwrapped chocolate. So what does the word first here mean? So it means that all the chocolates before it did not satisfy the condition. So if we consider these events as separate, like even A and this is even B, then in even A, it means that the first chocolate was not gold, but the second chocolate was gold. And in even B, it means that the first four chocolates were wrapped and the last chocolate, or the fifth chocolate, was unwrapped. So we want to find the probability of A given B. And according to Bayes' theorem, or if you use Venn diagrams, you'll notice that probability of A intersection B, or A and B, divided by the probability of B, gives us A given B. So given that B happened, we want to find the probability of A happening. So we want to find the probability of chocolate 1 not being gold and the chocolate 2 being gold, given that chocolates 1 to 4 are wrapped and 5 is unwrapped. So let's find probability of B first. It's very simple. It's just equal to the probability of getting 4 wrapped chocolate, so 1 minus 0.45 to the power of 4, multiplied by 0.45. And this is going to be on the bottom of the fraction, because we're going to have to find probability of A and B now. Now, we have to be careful here, because when they say A intersection B, it means that we have to satisfy both events. So A has to be true and B has to be true as well. We can't just have either or. So the first 4 chocolates have to be wrapped, and the first chocolate has to be not gold. So the first chocolate is both not unwrapped and it's also not gold, and the only other possibility is red, so it's going to be 0.25 times the rest of the probabilities, because the first chocolate must be red and the second chocolate must be gold because of even A. But then the next are determined by even B, which is going to be 1 minus 0.45 squared, because chocolates 3 and 4 can either be gold or red, it doesn't matter. And then chocolate 5 has to be unwrapped. So if we put this into a fraction, you'll notice that the 4 and 2 here, they cancel, and then these also cancel, and we're left with 0.25 times 0.3 all over 1 minus 0.45 squared. And this is equal to 0.248. So if you got this as your final answer, then you're on the right track. Because as outlined in A intersection B, if you use Bayes' theorem, then you know that the probability that we get a red chocolate, gold chocolate, and red or gold, and then an unwrapped chocolate is going to be A intersection B. If we divide all of this by the probability of B, which is just going to be wrapped chocolates and then getting an unwrapped chocolate, then you'll get the right answer. Well, there's also another way you could do this or arrive at this fraction. Another way is to just basically see that these cancel out. This will cancel out. This and this and this will also cancel out. And the reason for that is if the first 4 chocolates are wrapped, then it means that the first 2 chocolates are wrapped. And once we pick the first and second chocolates, then no matter what else we pick after that, it won't affect the probability of getting a unwrapped chocolate, a wrapped chocolate, or gold or red chocolate in the first 2 selections. So anything after turn 2 doesn't matter. So with that in mind, we can just say the probability of getting a red and then getting a gold divided by the probability of getting 2 wrapped chocolates is the same or is equivalent to what we did before, or what the question is asking. So as part of a tree diagram, I guess you could say that you get a wrapped to unwrapped, and if you multiply 0.25 times 0.3, this will be red and then gold, whereas 1 minus 0.45 times 1 minus 0.45 is not getting unwrapped and not getting unwrapped on the second turn. So those are the 2 ways you can solve the question, and if you found the video helpful, Please subscribe.